These are the problems on chapter 13, slide 6 lecture. The problems are about writing equilibrium constant expressions. That is the first step that after balancing, of course, balancing the chemical reaction. That is the first thing that you need to learn to do, is how to balance or how to write equilibrium constant expressions. Let's take the first example. We have 2SO2 gas plus O2 gas. And now we have a double arrow denoting both the forward and the reverse reactions. 2SO3 gas. Now the phase, the state functions here, they denote the phase, which is important because, as we mentioned in the lecture, if we see an L or an S, those do not appear in the equilibrium constant expressions. So if it's G or AQ for aqueous, then yes, they do appear. Let's first make sure that it's a balanced reaction. 2 sulfurs, 2 sulfurs, 2 and 2. There's 4 oxygens. 2 times 3. There's, 2 times 2 is 4 oxygens plus 2 is 6. 2 times 3 is 6. So it's a balanced reaction. Okay, writing an equilibrium expression Kc for this reaction. I know I'll have a quotient, so I will have a fraction. The products are going to come on top, the reactants are going to be at the bottom. And do not get mixed up with the 2 right now. My only product is SO3, so I'll have the concentration of SO3 denoted with square brackets, raised to the power of 2, because that is my molar coefficient in front of SO3, okay, squared. And then at the bottom, I'm going to have each of my reactants concentrations. So SO2, concentration of SO2, raised to, once again, the second power, because that's the molar coefficient in front of SO2, multiplied by the concentration of oxygen, O2. It doesn't need to be raised to any power. I mean, it could be the first, but it's implied. So this is the equilibrium constant expression for this particular reaction here. Let's do the next one. I have lead 2 chloride as a solid, giving me lead 2 plus aqueous plus 2Cl minus aqueous. This is also balanced. I have 2 chlorines and 2 chlorines, 1 lead, 1 lead, so it's balanced. And my charges are balanced. 2 times minus 1 is minus 2 plus 2, so I am good to go. Now let's write the equilibrium expression for this particular reaction. On my product side, I have lead 2 plus and chlorine 2 minus, so I'll write concentration of lead 2 plus. I don't need to raise it to any power because the molar coefficient is 1, multiplied by the concentration of chlorine minus, raised to the second power, because it is the molar coefficient in front of chlorine. Now, I do not need to put anything down here because PbCl2 is a solid, which means that its concentration is going to be 1. So I have my product here divided by 1. I don't need to write it. So this is the equilibrium constant expression for this reaction here. Let me erase this and then we'll go on. I will do a couple more and then you can finish off the rest of them as practice you'll have enough examples to help you do that. And the more practice you get, the better, obviously, you'll be at it. Okay, let's see. Let's do the fourth one. So I have P4 as a gas plus 5 oxygens as a gas. Once again, the double-sided arrow, giving me P4O10 as a solid. Okay, now let's make sure that it's balanced. 4 phosphorus, 4 phosphorus, 5 times 2 is 10. 10 oxygens over here. It's already balanced, so I don't need to do anything else. Let's write the equilibrium expression Kc for this reaction. Well, I will have a quotient. On this side, I have a solid which doesn't appear in the equilibrium constant expression, but I have to put something up here anyway. I will put a 1 because that's the concentration of that will be a 1 over the concentrations of the phosphorus and the oxygen raised to their respective molar coefficients. So this is concentration of P4 raised to the first power, because that's 1, multiplied by the concentration of oxygen, O2, raised to the 5th power, because that's the molar coefficient in front of oxygen. This is the Kc expression for this reaction. Note that even though we don't have, the concentration doesn't appear, but I have to put a 1 there anyway to make the quotient. So it's 1 over the concentrations of my reactants raised to their particular molar coefficients. As a solid, that doesn't appear. So make sure when you see an S or an L, you do not put those concentrations in the equilibrium constant expression. Okay, I have done 4 out of 7. You have 3 more to practice on. Go ahead and do those, and if you need any help with them, just let me know.